Let's start permutations and combinations. In this chapter, the first topic is sum rule and product rule. Okay, so let's get an idea about this topic, sum rule and product rule. I'll take an example of samosas and momos. Okay, so let's say you have three types of samosas and two types of momos. Okay, let's give them a name. Let's say you have aloo samosa, you have onion samosa, and you have chicken samosa. Okay. Then let's say in momos, you have two varieties. You have veg momo and you have, let's say, non-veg momo. Okay. Now, let's say you want to have a snack. You want to have a snack. Okay. That means you want to eat, you want to eat, you want to eat. So when I say you want to have a snack, you want to have either an aloo samosa, you want to have or you want to have aloo onion samosa, or you may want to have chicken samosa, or you may want to have veg momos or non-veg momos, any one. Okay. So that means you want to eat either a samosa in which you have three varieties or a momo. Right? When I say you want to have a snack, you want to eat either a samosa or a momo. So that means how many choices you have now? Total choices. Three for samosas and two for momos. So total choices, how many you have? You have five choices. So this is nothing but sum rule. Okay, I'll give you the definition of sum rule, but this is a small example where you can apply sum rule. Okay, so when you have choices, when you have varieties, there are three types of samosas and you have two types of momos, right? And you want to have a snack, right? And the total choices that you have is 3 plus 2, 5. Because you want to have either a samosa or a momo. Okay. Let's take an example of product rule. Let's say you want to get ready for a party. Okay. And you have three shirts and two pants. Okay. Let's say you have three shirts and two pants, and you want to get ready for the party. So that means what? You want to wear a shirt and a pant for the party, right? You want to wear a shirt and a pant. So how many choices of shirt you have? You have three choices of shirt, and you have to wear two pants. So, I mean, you have to wear any of those two pants. So 3 into 2, that many choices you have. Yeah. So how many choices you have? You have six choices. Yes or no? What are those choices? Let's say the shirts are SA, SB, and SC. These are the shirt names. And let's say the pants are P1 and P2. Okay. So I can wear SA with P1. I can wear SA with P2. Or I can wear SB with P1, or I can wear SB with P2, or I can wear SC with P1 and SC with P2. These are the six choices I have. 1, 2, 3, 4, 5, 6. So whenever you have scenarios where you have to do both the things and you have options in both the things, then the number of choices that you have is 3 into 2, 6 choices. So you'll basically multiply. Whereas the scenarios, like the previous scenario, where you have to do either this or that, right? In that case, you will add the choices that you have. So the five choices that you have in the previous example, in this example, the samosas and momos example, that the five choices you have is what? You can either have aloo samosa, or you can have onion samosa, or you can have chicken samosa, or you can have veg momos, or you can have non-veg momos. Okay? All right. So these were two small examples to understand the sum rule and product rule. Now let's get into the definition. So sum rule says that if a task A can be done in n of A ways, and task B can be done in n of B ways, then either of the tasks can be done in n of A plus n of B ways. Okay. So if task A can be done in n of A ways and task B can be done in n of B ways, then either of the tasks can be done in n of A plus n of B ways. That's the definition of sum rule. Okay. Let me take another example here. Let's say you have two sets, set A and set B. Let's say there are three elements in set A and there are four elements in set B. Okay. Now, if I say, in how many ways can you pick an element? Can you have an element from set A or B? The number of ways in which you can pick an element from either set A or set B will be equal to number of ways in which I can pick an element from set A plus number of ways in which I can pick an element from set B. So that is 3 plus 4, 7 ways. Okay. So there are three elements in set A, there are four elements in set B. Okay. And I'm asking you to pick an element. Right? So how many choices you have? You have 7 choices because you can pick either of those three elements which are there in set A, or you can pick any of the four elements that you have in set B. Okay. Now there is a small variation to this sum rule. Okay. There is a small variation to this sum rule. Let's say you have two sets like this, okay, which are overlapping with each other. Okay, so the example that we have seen here was a disjoint set example where the elements are not overlapping. Okay, but you can have non-disjoint sets also where the elements are overlapping. Okay, so let's say A and B are two sets. And let's say the set A has 4 elements in it. Okay, 1, 2, 3, 4, out of which 2 elements it is sharing with B. Similarly, let's say set B has 5 elements in it, out of which it is sharing 2 elements with set A. Then the number of ways in which I can pick an element from A or B is equal to number of elements in A plus number of elements in B minus the number of elements which are common in both A and B. Okay, so how many elements are there in A? 1, 2, 3, 4 elements are there. How many elements are there in B? 1, 2, 3, 4, 5. And how many are common elements between both the sets? 2. So 9 minus 2, 7. So if you see, there are 7 choices that I have. If I have to pick an element from either A or B, I have 7 choices. Okay, but the way the calculation is being done, if you notice, is it in this way because you have overlapping elements. If you don't have overlapping elements, if you have disjoint sets, then you can just apply this n of A plus n of B. Okay, all right. Next, let's see the definition of product rule. The product rule says that if task A can be done in n of A ways and a task B can be done in n of B ways, then both the tasks can be done in n of A into n of B ways. The example of getting dressed, like you have 3 shirts and you have 2 pants. So the number of ways in which you can get dressed is 3 into 2, 6 ways. All right. So the concept is simple. Whenever you have to apply sum rule, you will do addition. Whenever you have to apply product rule, you will do multiplication. Whether to apply sum rule or not, you can check if you're seeing the words like either or in the question, you'll apply sum rule. If you are seeing the word and in the question, then you can apply the product rule. Okay, makes sense. Let's see some questions. Let's see this question. The set 2, 3, 4, 5, 6, 7, how many elements are even? How many are prime? How many are odd? How many are even or odd? How many are even or prime? And neither even nor prime. Okay. So let's solve this. So first it is asking how many elements are even. Can I say that there are three elements? There are total six elements here, out of which three are even. What are those three? 2, 4, and 6. 2, 4, and 6. How many are prime? How many are prime numbers here? You have 3, you have 5, sorry, you have 2. 2 is a prime number, 3 is a prime number, 5 is a prime number, and 7 is a prime number, right? So you have total 4. There are total 4 prime numbers. There are 3 even numbers. Okay. How many are odd numbers in this set? What are odd numbers? 3, 5, and 7. So you have 3 odd numbers. Okay. Now, let's see this question. How many are even or odd? How many are out of in this set? How many are even or odd? So tell me, even or odd, is it not a disjoint set? Yes or no? Are they not disjoint sets? So if I have to find the number of elements which are either even or odd, that means I have to calculate the number of elements which are even and plus I have to calculate the number of elements that are odd. So which is 3 plus 3, 6 should be the answer for the fourth question. Now tell me how many are even or prime? How many are even or prime? Now even or prime is a non-disjoint set because you have a common element, right? Are non-disjoint because there are three even numbers, there are four prime numbers, but two is common between them, right? In such cases, when you have to draw either even or prime, then it is equivalent to number of even plus number of prime minus number of such elements which are both even and prime. Okay, let's do the calculation here. So which is equal to how many elements are even? 3. How many elements are prime? 4. Minus how many elements are such that they are both even and prime. So 2 is that number which is both even and prime. So minus 1. So I have one such number which is 2. So the answer for this is 7 minus 1, 6. Last bit, sixth bit. Neither even nor prime. How many elements are neither even nor prime? This is equal to 1 minus, or sorry, 6 minus. I have to do 6 minus because there are 6 elements. Total minus number of elements which are even or prime. So 6 minus, how many elements are even or prime? Just in the fifth bit we have seen. There are 6 elements which are even or prime. So 6 minus 6, answer that you will get is 0. Okay? So whenever anyone is asking you to find the number of elements which are neither even nor prime, you can do total minus either even or prime count. So total is 6 minus either even or prime count is 6. So 6 minus 6 is 0. Okay. All right. Okay. Let's see one more question. In a library, there are 3 English books, 4 French books, and 5 Spanish books. Find the number of ways in which a book can be borrowed. Find the number of ways in which a book can be borrowed. And so we need to borrow one book. Our book is saying, right? So the number of ways in which a book can be borrowed is number of ways in which I can either borrow an English book or French book or Spanish book, right? This is similar to that samosas and momos example where you had 3 samosas and 2 momos and you can have one snack. This is similar to that. You have 3 English books, you have 4 French books, you have 5 Spanish books. Okay, the number of ways in which you can borrow a book is equal to number of ways in which you can select an English book or a French book or a Spanish book. which is 3 plus 4 plus 5. That should give you 12 as the answer. That's the second bit. The number of ways in which 3 books, each of different language, can be borrowed. So I need to borrow 3 books, and the 3 books should be of, each one should be of a different language. So I need to borrow an English book, and I need to borrow a French book, and I need to borrow a Spanish book, right? Well, I have to borrow 3 books, and the 3 books have to be different language. That means I have to borrow an English book and a French book and a Spanish book. So how many choices I have? 3 into 4 into 5? 60. This is similar to that getting dressed for a party example. Yes or no? Okay. Let's see the third bit. Number of ways in which 2 books, each of different language, can be borrowed. Now this is interesting because here we have to apply both product rule and sum rule. Okay. So when he says number of ways in which 2 books of different languages can be borrowed, so that is number of ways in which I can borrow English and French, or French and Spanish, or Spanish and English. So that is equal to number of ways in which I can borrow English and French plus number of ways in which I can borrow French and Spanish plus the number of ways in which I can borrow Spanish and English. So which is how many ways I can borrow English and French? 3 into 4. How many ways French and Spanish? 4 into 5. And how many ways Spanish and English? 5 into 3. So how much is that? 12 plus 20 plus 15, which is 35, 47 is the answer. All right.